Okay, we're going to take a look at number 23 out of chapter 9, section 3. Refer to data set 18, speed dating for the attribute ratings made by participants in speed dating session, females in column 9, males in column 10. Each attribute rating is the sum of ratings of 5 attributes. Sincerity, intelligence, fun, ambition, shared interests. Use a 0.05 significance level to test the claim that there is a difference between female attribute ratings and male attribute ratings. So we've got quantitative data here, but our scores are, what we have to make sure of is this independent or paired samples here. And what we have in these ratings here is we have females and males that get paired together. The females rate the male rates the females. So these are paired data here. And so our claim then, since it's paired data, is going to be about the mean difference. And they want us to test the claim that there is a difference between the female attribute ratings and the male attribute ratings. Well, there is a difference. That is kind of the opposite of there is no difference. No difference is equal to 0. There is a difference is not equal to 0. That could include less than, that could include greater than. So there is a difference is the English way of saying not equal. We're write out the opposite of the claim. So there's going to be the mu sub d, there's going to be the 0. The opposite of not equal is equal. So now we're ready to go ahead, write out our hypothesis statement. Again, HO and HA are merely labels. They are never equal to anything less than or anything not equal to anything. What is equal or not equal or less than or greater than is, in this case, our parameter mu sub d. Which one goes in the null hypothesis? What goes between the mu sub d and the 0? Equal, because it's always equal in the null hypothesis, which means our strict inequality, the not equal, goes in the alternate. And then when we put the R and the S there, it is the alternate hypothesis that represents the claim. So we're going to note the S there. So this is a two-tailed test because the inequality in the alternate is a not equal. Alpha is 0.05. And since we're working with raw data, there are no summary statistics to list out, at least not right now. So our rule of rejection, we're going to reject null hypothesis if p-value, because that's the method we've been using, is less than or equal to our alpha of 0.05. Our test statistic will be T. If you don't know that offhand, that's fine. StatDisk will tell you that. And again, I'm lining up the p-value here so it goes right underneath what we have in the rule of rejection. So we need to go over to StatDisk now and open up data set 18, and we're going to work with columns 9 and 10. So just to keep things in mind before we head over there, so females, that's going to represent sample 1. Males is going to represent sample 2. So heading on over to StatDisk, opening up data set 18, and we reach the conclusion that this is matched pairs because the males and females are rating up those who they were matched with. So we'll do that. Our alternate is not equal 0, so we don't have to worry about changing that. Our significance level is 0.05, so we don't have to worry about changing that. We said our sample 1 is going to be column 9. Our sample 2 is going to be column 10. We can hit evaluate. We can also hit plot. And we see that our blue is not off in either of the tails there. So our test statistic 0.191. So we're not even 0.2 of a standard deviation away of what we'd expect if they were equal. So let's head back here. There we go. So our test statistic 0.191, p-value 0.8485. And 0.8485, that's nearly 85%. 85% is not less than 5%, so we will not be rejecting the null hypothesis. We got a result that is very consistent with the idea that there is no difference between the attribute ratings from each group there. So fail to reject. When we fail to reject, we don't have the evidence, or as they tend to say it in my stat lab and the textbook, we have insufficient evidence to blank the claim that, and we fill in the blank with what we noted back in the hypothesis statement. We noted the S, and S is for support. So we have insufficient evidence to support the claim that there is a difference between female attribute ratings and male attribute ratings. And wow, what horrible penmanship there. Sorry about that, folks. So we put together our conclusion in 3 separate spots. It's always a good idea to go back and read it all the way through start to finish. We have insufficient evidence to support the claim that there is a difference between the female and male attribute ratings. So we don't have the evidence to say that they're different. If we don't have the evidence to say that they're different, we don't say that they're different. So does there appear to be a difference in the attribute ratings? No. If so, which group is giving the higher scores? Well, we said no here, so there's nothing to answer in part 2 of that. Now, just to take a quick look at what the confidence interval is telling us here. What we see here is 0 is in the confidence interval of the mean of the differences. So we can't conclude that the mean of the differences is not 0, which is exactly what we did when we failed to reject the null hypothesis. We failed to reject the idea that the mean is equal to 0. We weren't able to get rid of that. We weren't able to conclude otherwise.